Okay. Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera pada semua. Okay, so video ni is berkenaan dengan the second subtopic of topic 2, which is about uniformly accelerated motion. Okay, so before this, Madam dah pun mention maksud uniform dekat sini adalah constant. Okay, so constant acceleration. So means that the acceleration is not increasing or decreasing. Okay, so acceleration is fixed, constant. It's tidak berubah. Okay, sebab tu kita ada graph of acceleration time graph before this. Okay, di mana shape of the graph for AT graph, it is either horizontal line. It means it is fixed at certain value. Either it is above the x-axis, or the horizontal line lies on the x-axis, or the value of acceleration is below the x-axis. So it means it is in negative acceleration. Okay. So physics matriculation, the acceleration is uniform. Okay. So uniform constant acceleration means velocity changes at uniform rate. Okay. So kadar perubahan velocity berubah pada kadar yang fix, kadar yang seragam. Okay. So that is uniform acceleration. Okay. So there are five physical quantities about linear motion. Okay, so we have 5 quantities. Okay, the short form for the 5 quantity is SUVAT. Okay, S for displacement, V for initial velocity, V for final velocity, A is for acceleration, and T is for time. Okay, so SUVAT as a short form. So there are 5 physical quantity in the linear motion. Okay, so next we have 4 kinematics equation. So 4 equation untuk linear motion. Okay, so madam rasa korang dah pun belajar, dah pun jumpa equation ni dari sekolah menengah lagi to solve problems of linear motion. Okay, so the first formula is V equal U plus AT, S equal half U plus V times T, S equal UT plus half AT square, and V square equal U square plus 2AS. Okay, so from the 5 physical quantity, 4 of them are the vector quantities. Okay, so tadi madam kata SUVAT, right? So S, U, V, A are the vector quantities. It means that it has velocity, it has magnitude and direction. Okay, so we must take into account the direction of these 4 quantities. It's very important in physics, direction of the quantity. So we have to take into the account the directions while we substituting the value. Okay. So next, in the problems, in the question, okay, so the question is just a statement. So there is a few key points that we need to know. If it is said that the object is initially at rest, it means that the object is not moving, thus the value of initial velocity u will be equal to 0. If the question said that there is a deceleration made by the object, or the object is decreased in velocity, or the car is pushing a brake, okay, so it means that the velocity is decreasing in time. Okay, the initial velocity is greater, the final velocity is smaller than the initial velocity. It means that the object is decelerated, so the value of accelerations given must be in negative value. Another keyword, if it states that when it is finally the object stop, okay, so it means that the final velocity, the V, is equal to 0. Another keyword, if it said that the object move with uniform velocity, it means that the object doesn't change its velocity. So moving with a constant velocity means the value of accelerations of the object is equal to 0. Okay, for this video I would like to teach you about the derivation of four equations here. So how to get the formula, how to derive the formula. So basically, we derive the equation from a graph of velocity time graph. Okay, so here is the shape of the graph, means the object at initial time, the object has velocity of u. Okay, so the object increases its velocity, increasing in velocity until the final velocity v at time t. Okay, so we have learned before the concept from velocity time graph. Okay, the concept, we can get the gradient of the graph. Okay, from the gradient of vt graph. Okay, so gradient is minus, right? So v over t, we will get acceleration. Okay, so kita boleh cari gradient of the graph dari sini. We have the two coordinate, right? So this coordinate is 0, u. The second coordinate is t, v. Okay, so we can get the gradient of the graph. So gradient of the graph equal acceleration. So acceleration equal v minus u over t minus 0. So here is the equation of acceleration. A equal v minus u over t. So make v as a subject. So we will obtain v equal u plus at. Okay, so make v as a subject. Kita pindahkan t to the left hand side, and then u kita pindahkan to the left hand side will be plus. So v equal to u plus at. That is the first equation for the kinematics equation. So we obtain the equation from the graph is from the gradient of the graph. That is the first concept that we have learned before. The second concept that we have learned about velocity time graph is from the area under the graph. The area means it is in operation of times. Okay, so multiplication. Okay, so v times t, we will get as displacement. V times t, we will get displacement. Okay, so displacement equal to the area under the graph, and here is the area under the graph. It is in the shape of trapezium. Okay, so to get area under the graph, which is the displacement, adalah from the trapezium shape. Okay, so ingatkan formula trapezium, it is half times the parallel line. Here is the parallel line of the trapezium. Okay, so it has u for the first side and v for the second side times with the height of the trapezium, which is t. So we will get formula of displacement from the shaded of the graph is equal half times u plus v times t. So that is the second formula for the equations, kinematics equation, okay, from the area under the graph. So it is in the shape of trapezium. Okay, from these two formulas, okay, so we have formula 1 and formula 2, we can derive the next equation, the third equation, okay, by just substituting the equation. Okay, so substitute the equation 1 into 2. Okay, so equation 1, we have v here as a subject. We can substitute v of the first equation into second equation. So S equal half times U plus the V is U plus AT times with T. Okay, So u plus u, okay, here, the side here, from this side. Okay, 2u plus at times t. Okay. So in front, kita ada half dekat sini. Okay. So kita boleh cancel 2 dekat sini sebab darabkan dengan separuh. Okay, so 2 akan cancel. So half ni akan darabkan dengan at sahaja. So sebab tu kita akan dapat, okay, t ni kena darab at both side. Sebab tu kita akan dapat s equal ut plus half at square. So the third equation is here. Okay. So kita dapat dah the third equation. Okay, now the fourth equation, the final equation. So to get the final equation, we substituting the second equation, the first equation into second equation. Okay, still the same lah. Okay, so kita ada second equation, s equal half u plus v. Okay, so u plus v, same here, v plus u, and substitute the time, make time as a subject from the first equation. So time equal v minus u over a. Okay, so substitute time here dekat sini. So v minus u over a. Okay, so kita pindahkan 2a to the left hand side. So kita akan dapat 2as. Okay, so here is v plus u times v minus u. Okay, so kalau kita buat v plus u times v minus u, kita kembangkanlah kita punya equation ya. V square minus uv. Okay, so next here is plus uv minus u square. Okay, so u times u ada negative, so minus u square kat sini. So plus and minus uv ni kita boleh cancel, so kita akan dapat v square minus u square. Okay, so the right hand side kita akan dapat v square minus u square equal to as. So yang minus u square ni kita pindahkan to the left hand side. So kita jadikan v square as a subject. So kita akan dapat v square equal u square plus 2as. So we can obtain the fourth equation of linear motion from here. Okay, so that's all for this video. So hopefully you are familiar with these 4 equations of linear motion. So nanti kita akan sambung lagi kelas kita pada hari Isnin nanti. Okay, thank you very much.